Come.
Yes.
Okay, let us do today resonance. It's a LCR circuit. So, what is the use of this LCR circuit in the sense? So, it's been used in tuning circuits to receive the signals from the audio station and TV stations. So, we'll see what is the aim of this experiment in the sense we're going to find out what is the resonant frequency of this LCR circuit when capacitor and resistor and inductor is connected in parallel or series. We will get some resonance frequency that we are going to find out what is the resonant frequency of this LCR circuit. So this is the circuit diagram of LCR circuit. This is a frequency regulator where we can send AC current at different frequencies. So first we need to connect it to this. Frequency generator is connected. Here milliammeter, that's a milliammeter. It's better to use small wires. Next here there's a inductor symbol. Here there are inductors. Connect inductors. Next capacitor, and here there are capacitor. Next there is a resistor and there are resistors. So this is series combination of LCR circuit. See, inductor, capacitor and resistor are connected in series. So this is a series combination of LCR circuit. So we are going to find out what is the frequency resonance of this circuit. For that, we have to send AC signals at different frequencies. See here, we need to send AC current at different frequencies, 200, 400, 600, 800 like that till 8K, 8000. That frequency if you keep on sending, when the frequency of this LCR circuit matches with any one frequency, we'll get a maximum value in this. You see, this is the frequency what we are sending, and here this is a current obtained from this LCR circuit. If you plot a graph between this current and frequency, so we'll get a slowly raised up and again it comes down. This we call it as a maximum flow of current, and the corresponding frequency we call it as a resonant frequency of LCR circuit. So this is an experiment, and how we are going to see how we are going to do with the experiment, let us see. Switch on the frequency generator and switch on this keep it at minimum initially. So these are the knobs, and if you press this it will give out 100 times, and if you press this it will give out 1K. If you press this here 100K, and this is if you keep at a different frequencies. So if you keep at 2 times 100, that's a 200 like that. This is a frequency. This is a duty cycles. Next, this is amplitude. So we need to keep this amplitude at constant, and we are giving 20 volts to get exact frequency of this LCR circuit. So here we are giving sine waves. So once it is keep this is constant, no need to touch that, and we have to just press this and keep increasing. So initially if you see, this is a 200 hertz, and keep it at 200 hertz. there is a mark and keep it at 200 hertz. See the what is the current, you just write it down. Next keep it at 400 and see the current is obtained, and note it down and keep at 600 and see the current and note it down. If you slowly keep on increasing, here we can find out current also increases. Once it reaches to the maximum, again it will start decreasing. So 3.9, 4, 4.2, 4.3, 4.4, 4.5. So here the frequency what I have kept is 1000. Now what we have to do is we have to bring it back and press 1K. That means that 1000 hertz we are giving to this circuit. So you see 4.7 and you increase 1.2K and 1.4K. If you see this current, slowly it increases 4.9. So if you observe this, so it has reached to 4.8. Again it is started coming down. If we keep on increasing frequency also, its current value keep decreases. See, so I'm increasing frequency and but current is decreasing. Yeah. Till 80K, just note down the current and initially slowly increases at particular frequency. It reaches maximum value and again it comes down. If you plot a graph between this current and frequency, you will get a curve like this, as I told you before. So this is I max. The corresponding frequency we call it as a resonant frequency. So next one, in this experiment we can calculate unknown inductor also. If you know frequency and if you know resistance and capacitor, we can calculate the self-inductance of inductor also can be calculated. And also bandwidth. So bandwidth in the sense, so FB minus FA. What is meant by FB minus FA? So if you see this graph and we got I max and you divide that I max current divided by square root of 2, you will get a value here, and if you just draw the line, it will meet at two frequencies. So that lower frequency we call it as FA and higher frequency we call it as a FB. The difference in the frequencies we call it as a bandwidth. So bandwidth in the sense, if you see the radios or FM tuning circuits, if you keep on tuning, once it reaches this lower frequency, we will get a signal, but that voice is not clear. If you keep on coming towards here at the resonant frequency, we will get clear voice, and keep on tuning again, so we lose the signal at this frequency. At which frequencies, the range of the frequency where we get a signals, that we call it as a bandwidth. So that's what we are calculating from here. And also quality factor can be calculated of a LCR circuit. Quality factor Q equal to F naught by delta F. F naught in the sense resonant frequency, what we have calculated from here, and delta F is nothing but bandwidth. If you substitute in this, we can calculate quality factor of LCR circuit in series combination. So next one, we can do the same connection for parallel, same experiment for the parallel combination. So parallel in the sense inductor, resistor and capacitor. The capacitor is parallel to the inductor. So let us see how we can connect it over here. We just take out the capacitor and switch on, switch off, and take out the capacitor. Here the parallel combination is there, and you just connect it to this, and we just short it out. So this is a parallel combination of LCR circuit. You repeat the same procedure. How we have done before, we have kept these frequencies at 100 times and we have switched on and remaining the same. So here we have kept it 100 times. You just increase this one to 200 hertz. The same thing, 200 hertz. And what is the current here? But in parallel combination, initially we'll get a high current. And if you keep on increasing frequencies, we'll get the less current. The current will decrease slowly. And if you keep on increasing these four frequencies, we can observe that there is a decrease in current. In parallel combination, the current will slowly decreases, reaches to the minimum value, and again it will start increasing on increasing frequency. So I have kept this frequency at 100. Again, if you want to go for the 1K, just go back and keep it at 1K and keep increasing this. So I'm increasing frequency, but the current in a LCR circuit keep decreases. And it decreases, again it will start increasing. Just now we have observed that it was 1.79. Again on keep increasing this frequency, this current started increasing. So if you keep on increasing frequency, and its current will start increasing. So in parallel combination, we will get initially high current. On increasing frequency, we will get low current, reaches to the minimum current. Again, on keep increasing frequency, it reaches to the maximum current. Right? So if you plot a graph between this frequency and current, so initially high, slowly it decreases, reaches to the minimum, and again it will start increasing. At which frequency we got minimum current, that we call it as a resonant frequency in parallel combination. Next, in this case, we can calculate inductor also. The same thing here, L equal to 1 by 4 pi square Fr square. Fr square in the sense resonant frequency only, or F naught, and C is a capacitor. We can calculate inductor also. Next one, so bandwidth. How can we calculate bandwidth in parallel combination in the sense? So here I minimum is multiplied by the square root of 2. In this case, it is divided by square root of 2. Here multiplied by square root of 2, we'll get a value somewhere here. And if you draw the line, it cuts the curve at the 2 points. The minimum frequency we call it as low frequency, and this we call it as high frequency. The difference between these two frequencies we call it as a bandwidth, and this is nothing but bandwidth. In the same way, quality factor can be calculated from the parallel combination by the same formula. Quality factor is equal to F naught by delta F. F naught is resonant frequency, what we got from here, and delta F is nothing but the difference between these two frequencies. So quality factor can be calculated from the LCR circuit. That's all.